This is the first in a two-part series where I'll be looking at creating a method for adding a login screen to your app and being able to manage the presentation of the correct view based on the status of your login authentication without either using a navigation stack or a modal sheet. In the series, we're also going to be exploring biometric authentication with Face and touchID, along with securely storing your credentials in the KeyChain. Hi, my name's Stuart Lynch. In this first video, we're going to simulate the API call to some fictional service for authentication before being able to see the content. We'll be building out the app so that you'll be able to add this structure to any project and be able to present meaningful error messages to your users. In the second video to follow, once we've authenticated using an email and password, we're going to give the user the ability to authenticate using a biometric option if they want, and securely store the authenticated credentials in the KeyChain. Now before I get started, please leave a comment below if you enjoy the video, and give it a thumbs up and subscribe to my channel. Make sure you ring the bell to get notified of new videos. And if you want to support my work, you can buy me a coffee. I'll leave a link in the notes below. If this is something you want to learn, keep watching. I've created a starter project for this and you can download it from the link provided in the description below. There's not much to the project. There's one view, and that's the content view that will be displayed when the user is finally authenticated. There's no login screen yet. We have to create that. And we need to be able to branch from that login screen to our main app when authenticated. I don't want to use a navigation stack or modal sheet view, however, so we're going to have to determine a way to do that. For convenience, I've also created a simple model called credentials that has two properties, an email and a password. Both are strings, and both are initialized as empty strings. I've also created an API service class. An instance of the credential object will be used as the argument when calling the API service login function. This simply simulates a call to an external API that is asynchronous since it takes some time to authenticate and return a response. In my simulation, if the password submitted is the word password, the authentication is successful and the completion handler result is a success with the Boolean true. If it isn't, the completion handler result is a failure with, at this time, an API error. I've also created some assets that we can use to spruce up our application a bit. And this includes an accent color, the app icon, and two images, one that's used for the content view and the other one for our launch screen. We're also going to be putting that login screen image on our login screen as well. And finally, there's a single extension that will allow us to dismiss the keyboard if we tap outside of our login entry fields. So let's get started. Our first step is to create a login view. And it's going to be pretty simple. It's going to have two text field entries. One of them will be secure and a button to log in. I'm going to be using the MVVM design pattern here, so let's first create a ViewModel file where we can create this object and any other properties that our view might need, along with a function needed for logging in. So we'll call this file LoginViewModel, and inside that file we'll create a class of the same name that will conform to the Observable Object Protocol. When we present our form, we want the email and password fields to be empty. So let's create a published property called credentials that will be a new instance of our credentials object. And remember, both properties are initialized as empty strings. We're also going to be showing a progress view that will initially not be shown, but will appear when the user taps on the login button and then disappear once the authentication process is complete. So to toggle the state of visible or not, we can create a Boolean property called showProgressView and initialize it as false. Now since our form will also have a login button, we'll also want to make sure that that button is disabled unless the user has entered an email and a password. So I'm going to create a computed property called loginDisabled that is a Boolean value that'll be true if either the email or password properties are empty strings. Next, we'll need a login function that will log into our server using the API services login function. Now this function will have one parameter, and that will be a completion handler that is a closure with a Boolean value as its parameter, returning nothing. And since this closure will escape, we need to mark that function as escaping. Now the first thing we want to do within the body of our function is to show our progress view. So we'll set that property to true. Next, we'll call our API services login function. Now API service is a singleton and the login function is a static function of the shared singleton. So we'll use the API service.shared.login. And it has two arguments: credentials, which is our published property, and a completion handler that uses a result type as its argument. So we can call it result, and it is a result tuple with a Boolean success and an API service.API error as the error type. And within the code block, we can change the state of our show progress view to false, since we will have received a response back from the server. And because we do update show progress view within the function, we'll need to capture self so as not to create a possible memory leak. We can now switch on the result. If we receive a successful result back, we'll complete with true, and we can ignore the associated Boolean for now. If it fails, we're going to ignore the associated error here as well, and we'll be setting our own error in a minute. Well, what we can do is reset the credentials by assigning a new one that has an empty email and password string, which is just another instance of credentials. And again, because we have captured self, we don't need to use self to access the property. Well, this is good for now. We'll come back to this shortly. Now it's time to create our login view. So we'll create a new file called LoginView, and that'll be a SwiftUI file. At the top of the view, I'd like to create an instance of our ViewModel. And for this, I'll use the state object property wrapper. Within the body of the view, I'll create a VStack. And inside that VStack, first, a text view with the string MySecureApp. And I'll format it using a large title font. Next, we'll create a text field for the email address with a placeholder of email address. And the text will be bound to the LoginViewModel's credential.email property. We'll also set the keyboard type to be an email address type. This will be followed now by a secure field for the password with a placeholder of the word password, and it'll be bound to the ViewModel's credentials password property. Next, we'll use a progress view that will be displayed only if the show progress view property is true. Following that is a button with the text login, and the action will be our LoginViewModels.login function. And this has a completion handler that will get either a true or false argument. We'll call this success for now and deal with it in just a minute. The button will be disabled if our login disabled computed property is true. Let's add a bottom padding of 20. And then I'll finish the VStack with an image of our login screen. Now when we tap on one of our form fields, the keyboard will be displayed. And in SwiftUI, at this time of the video, has no way to dismiss the keyboard. So I have created that shared extension that will allow me to end editing and thus dismiss the keyboard. So I'll call that function whenever the user taps on the image. So within the body of the tap gesture, I'll call that shared function. I want to add one more spacer to push the contents up to the top of the VStack. Now I want to make sure that the first letter of our two form fields are not capitalized, So we can set the auto capitalization to none. I'll set the text field style to rounded border text field style. I'll add some padding. And finally, when the progress view is showing, I want to disable all user interaction on the VStack. Oops, let me add one more S to that success here. So what do we want to do in that closure of that login function? If successful, we want to show our content view. If unsuccessful, we want to show some kind of error alert and allow the user to try again. So how do we do that? Let's work on that authentication part first. I'm going to create a new class that I'll be injecting into the environment, and this will allow me to track the current state of my login status. This means that I'll be able to log out of my main application and return to the login screen if this is what I want. So first, create a new file and call it Authentication. Inside that file, create a class of the same name that conforms to the Observable Object Protocol. For now, this class will have just one published property and one function. The property is a Boolean that we'll name isValidated, and we'll initialize it as false. I'm going to create a function that I'll call updateValidation, and it will have a Boolean property called success. And this is going to allow us to basically dismiss one view and present another, and we want to do this with some animation so that the transition will not be so stark. So first, change the import foundation to import SwiftUI, and then wrap our isValidated equals success inside a with animation closure block. Now that we have this class, we can inject it into the environment when our app launches, and that's where our @main attribute is located. So we can do this by creating a state object called Authentication that's an instance of the Authentication class. Now, since this class has a property that's called isValidated that's initially false, we can change the presentation of our first view depending on the value of this property. So if it's true, we'll present the content view, which is our main app. If it's false, we'll present the login view. And because we want to be able to change the isValidated state in both of our views, we can inject that instance of this class into the environment for both views as an environment object. Back now in LoginView, let's create an environment object property. Now that we have it, we can call the function in our login button, passing in whether or not our login was successful or not, because you will recall that login function had a closure that provided us with the success or failure Boolean that came from our API login function. If you test your app now and run it, you'll find that the login screen is presented since isValidated is false at the start. Notice as well that the login button is disabled as the two fields are empty. Now remember, in our dummy API, we get a successful login only if the password is equal to the word password. We can use any email address, but let's enter the word password into the password field. The login button is now enabled, so I'll tap on it. We get the progress spinner, and our main view is eventually displayed. We're inside our main view. Now, one more thing I want to do in this section is to add a logout button to the navigation bar here that will set isValidated back to false, and thus hopefully refresh our app's views and return us back to the login view. So back now in Content View, I'll add a toolbar modifier. And in the toolbar, I'll add a toolbar item with a placement of navigation bar trailing. And it has a button with a title logout. The action will need to access our authentication class that's been injected into the environment. So we'll need to add that property to our view as an environment object. And then we can update our validation by passing in false to the update validation function for our authentication. Let's run once more. Now the thing I forgot to test first was when I tap on a field and the keyboard appears, you can tap on the image to dismiss the keyboard. So make sure you choose from the I/O menu that the first two options of the keyboard menu are also selected. Now when I tap on a text field, the keyboard is shown. If I tap on the image, it exits the field and the keyboard gets dismissed. That's exactly what I want. Okay, let's log in again with any email and the correct password. Once logged in, I see a logout button on our new content view. And when we tap it, we return back to the login screen. Perfect. Now what happens if we type an incorrect password? We get the progress view displayed and then it removes the text field entries and does not proceed. We should really give the user more information on this. In fact, there could be many different reasons for this besides a bad password. There could be a network error, or as you'll see later, we might get a biometric error. So what I want to do is finish off this video to create a new error type that I will use in multiple places, but they all relate in some form or other to authentication. So within the Authentication class, I'm going to create a new enum called Authentication Error that will conform to the error protocol and the localized error protocol and the identifiable protocol. It's going to have one case that I'll call invalid credentials. We will add more in the next video. Now, since we're conforming to the identifiable protocol, we need to have an ID property. And since we're conforming to the localized error protocol, we will need to provide an error description that will be unique for each of our cases. So for the ID property, I'll make it a computed property that simply returns the localized description for the case. For the error description, it's an optional string computed property. So I'll switch on all cases as there may be many of them eventually. We only have the one, and I'll return an NS localized string describing the error like this. Well, now that we have this error, we can return to our API service, and instead of returning an API error in our completion handler, we can use an authentication.authentication error. And then when we fail due to an incorrect password, we can complete with an invalid credential error. We have no need now for this API error enum. Now, if you're using a real API, there may be many reasons for failure, so you can just add more enum cases to the authentication error cases and fail with an appropriate case. This provides us with a nice string that we can use as a message in an alert. So back in the login view model, I can create an optional published property called error that is one of our new error enum types. Our login function is showing an error because it no longer is getting an API error as a result, but rather an authentication.authentication error. So let's change that. And since we're getting that back, we can capture that in our failure case now and assign it to our new error property. Well, now that we have an error, we have the localized description. So finally, in LoginView, we can present an alert whenever that error property is not optional. And we can use our localized description as the message. The alert's item is bound to the LoginView model's error property that gives us that error. We can then present a simple alert with a title being text view showing invalid login, and the message being another text view using the error's localized description. Let's test. We can try to log in with an invalid password. This time we get an alert telling us what the problem was. Perfect. Well, that's the end of part 1. Already, I think we have a pretty good framework for adding a login screen to our apps and to manage the transition from the login screen to our application, along with providing the user with a meaningful feedback if the login fails. The way we've structured this code now will make it easier for us to add in more features that we will do in the next video. We're going to be adding an optional biometric authentication that will be able to access your credentials that have been stored safely in the KeyChain.